Here, the Perseverance rover continues the search begun by Curiosity. Its robotic arm, a precision instrument, examines the Martian surface, seeking evidence of past life in these reddish soils. The dark tones suggest a different mineral composition, perhaps basalt. Its layered structure represents millions of years of Martian history, each layer a different chapter in the planet's evolution. This area was once underwater, part of an ancient lake system. Rover's 6 treaded wheels, each 50 centimeters across, navigate this terrain with careful precision. Angular rock fragments litter the surface of larger rocks broken down over time. This granular regolith is evidence of erosion shaped by ancient streams and a thin atmosphere, just 1% of Earth's. These sedimentary layers suggest a long-lived lake, potentially existing for millions of years, habitable environment. Sunlight filters through the thin Martian atmosphere, creating a bright glare. This light powers Curiosity, not through solar panels, but a radioisotope thermoelectric generator essential for its mission. The dark dunes and ridges, the complex geological processes that have shaped this over billions of years. Martian sky appears hazy, a result of fine dust particles suspended in the atmosphere. This dust scatters sunlight, giving the sky a pale yellowish hue, different from Earth's blue. Cluster of dark rocks sits at the base of a sedimentary outcrop. A dark circular feature draws the eye. The Mars Reconnaissance Orbiter, orbiting since 2006, provides high-resolution images helping to map features like this across the crater. Small, dark rocks are scattered across the reddish. These angular fragments suggest they haven't traveled far from their source, aiming at localized erosion and weathering processes. From orbit, the Mars Reconnaissance Orbiter broader perspective. The reddish-brown color comes from iron oxides, common on Mars. This lighter patch on the surface is a point of interest, chosen for its unique color and texture. Rover's mastcam, with its 13x zoom capability, helps identify these areas for closer investigation, searching for evidence of past habitability. These features suggest erosion by wind and possibly water. The rocks themselves are primarily basalt, a volcanic rock, indicating a period of intense geological activity early in Mars' history. The internal structure of this patch is becoming clearer. The texture of the patch is slightly rougher than it initially appeared. It could be due to weathering or the presence of different grain sizes. Rover's wheels, each with 6 treads, navigate this terrain with precision, moving back, the patch in the context of the larger. The surrounding rock displays a more extensive layered structure, with larger scale features visible. Polygonal cracks suggest repeated cycles of wetting and drying, aimed at a past where water flowed freely across this. Another SuperCam view, and another piece. They represent millions of years of geological activity, slowly shaping the Martian surface. From orbit, Mars appears as a rusty world, a planet roughly 150 kilometers across. Gale Crater, our focus, is a window into the planet's ancient past, formed around 3 billion years ago. Curiosity has already traveled over 28 kilometers, analyzing the basalt rocks that make up much of Gale Crater's terrain. Laser analyzes the chemical composition of this rock, even from a distance. This fine-grained regolith, the loose surface material, is constantly shifted by Martian winds. It's a mixture of dust and broken-down rock to the planet's erosive forces. Each of Curiosity's 6 wheels, about 50 centimeters in diameter, is designed for traction. These treads help the rover navigate the challenging terrain of Gale Crater, even on slopes. This is Gale Crater, a 54-kilometer wide impact basin near the Martian equator. Patterns on this rock are a geologist's dream. For 90 seconds, we focus on this fractured surface. Rover slowly scans this terrain, searching for areas of interest. The regolith here is typical of Gale Crater, a mix of fine particles and larger rock fragments, all bathed in the thin Martian atmosphere. Notice the circular feature with it could be a cavity formed by dissolved minerals, a potential sign of past water activity, and a target for further investigation.